Welcome back to the channel and another video on the MTR105, this time covering the capacitance measurement function and comparing it to Keysight and the MetraHit coil. So this will be my test setup. I have a number of capacitance boxes that you see there. Each one of those is plugged into an instrument. On the left, the MTR105 is on a 1 millifarad capacitor. That is the full scale for that instrument. The Keysight is on a 10 millifarad, which is its full scale as well, and the MetraHit coil is on a 300 microfarad, which in turn is its full scale. On the right there, I have the 8846A that's currently connected to a decade box. I'll use that as the test for accuracy against all the other instruments. And what I'll do is take each of the instruments through the decade box and also apply a couple of the capacitance boxes as well. Now I've actually already done these readings, so the table that you see at the end might be slightly different to the values that you see in the video, because I'm just going to flick through these values quite rapidly just to show you how the instrument operates. In terms of the range of the instruments themselves, the MTR105 can go from 0.1 nanofarad to 1000 microfarads. The U1461A can go from 0.1 nanofarads to 10 millifarads. And the MetraHit coil can go from 10 picofarads up to the 300 microfarad. So for me, for the kind of testing that I do, those instruments actually cover all of that range. So all of them in that respect would be fine for my purposes. But we'll run through the tests and see how they compare to one another in terms of function and accuracy. Okay, so the MTR105, the capacitance function is off of the LCR function. That's got a green color-coded screen here. You have the option of a 1 kilohertz test or a 120 hertz test. So for the actual function control, you can leave it set to auto and it will try and figure it out for itself. You can manually change it to capacitance, or you can manually change it to inductance. There is no facility to, although they call it an LCR mode, there doesn't appear to be a facility to manually select resistance. I guess you just use the 2-wire or the 4-wire resistance function within the instrument itself. Now the instrument doesn't appear to have a nulling facility as the other two instruments have, so I won't be able to take out the residual capacitance within this decade box. So what you have to do is take a reading with it set to 0 capacitance and then manually subtract that reading from each of the values that you record. However, it is quite a very low value and it'll actually be below the capacitance range of the MTR105. What the instrument does have that the other two do not have is a calibration function. So I can go, it seems to be a manual function to go anyway, so you select it over here on the right, you do the first open circuit test. And it's done that reading, and then it wants to do a short circuit test, so let's put both leads together there and go again. And calibration succeeded. Tick again, and that's gone through its self-calibration mode there. So we'll flick it. 10 picofarad is its first setting. As I say, it won't pick this up anyway, it's beyond its range. So I'll tell you what, it definitely doesn't pick it up if you leave the leads stacked like that. Let's go again. So this is about as low as the instrument can actually read. It doesn't really like it that much. So what we'll do is we'll go to 0.1 nanofarads. I'll leave it with a 10 picofarad in there as well. Let's see what it comes back with. Doesn't like that one either. It's not good, is it? So let's pick that one up. Let's just go back to 0.1. Yeah, it seems to be reading it now, but it reads it as 0.2, so it doesn't seem to be very successful at the bottom end. I'll switch to. So as you start to go up through capacitance ranges, it seems to be a lot more accurate and happy, and it is a pretty fast response as well. Let's do 11.2. Okay, that's it on its decade box. We'll just do, I don't think 120 Hertz makes any difference, but no. Yeah, it certainly doesn't like the bottom end, does it? It's, so this is its maximum value it can withstand, which is 1 millifarad. And you can see against the 1 millifarad it is quite a little bit out. 964, 120 Hertz. That's just yeah, 1 kilohertz is even further out. Yeah, it doesn't seem too happy at the higher capacitance values at the top of it. Let's just try 300 microfarad. So it's, I mean, it's very fast, but it is a little bit out. That one as well. Okay, so that's the MTR105. I guess you get the general gist of the idea of how it operates. Seems to be adequate for motor testing for me, but we'll move on and test the MetraHit coil next. So with the MetraHit coil on the capacitance range, as far as the function switch goes and selection, this has its own single capacitance range, so as soon as you swan the function switch round, that's it. What you do have with this one is the ability to null the instrument, which we're reading 0.08 nanofarads residual capacitance on the box with it set to 0. I can soon take that out with press of one button, so we'll go up the decades on this as well. So that's 10 picofarads, which is 0.01 nanofarads. A little bit slower response. It should be 0.11. That should be 1.11 nanofarads. 10 nanofarads. It should give me 11.11. That should be 111.1. I'll add a 1 microfarad in. 1.111, which is spot on. And add a 10 microfarad in. Should be 11.11. He says. He's thinking about it, didn't it? Had a good think about that one. It's 11.28. So a little bit out there. And what I'll do is I'll pop it back into the 300 microfarad capacitance box. See how fast it responds to that. So that's reasonable. You'd have had a reading out of the MTR105 much quicker than that, but obviously it wasn't as accurate. So it depends what your preference is, whether you want speed and sacrifice a little bit of accuracy, or whether you want the actual slower reading, and it seems to be a bit more accurate with the MetraHit. Okay, so we'll switch over to the U1461A. So capacitance for the U1461A, it's off a multifunction position here, combined with the ohms, continuity, diode, and then the capacitance, which you select on the button here. There he is, 0.08 nanofarads, which was equivalent to the MetraHit coil. That's the residual capacitance within the decade box. As with the MetraHit, I can null that out on this instrument, so it's a direct reading. So we'll flick him up to 0.1 nanofarads, which we get. 0.11, again is accurate. 1.11, 1.13, 11.13, 11.2, 1.111 it should be. So you can see it's responding pretty quick. 11.29. Certainly on these ones it's a little bit faster up with the speed of the MTR105. Let's get rid of that and we'll go to the 300 microfarad. You can see it does start to slow down at the higher value capacitances. 0.298, but that's pretty accurate. That's not bad at all. And we'll then go for 1 millifarad. So again, not too bad speed wise. It is slower than the MTR105, but it does appear to be quite a bit more accurate. Okay, so just for a very quick comparison, we'll use the 8846A, and with this one you see 0.088 nanofarad residual. I can zero that on this as well, and then we can just go through these 0.017, 0.117, 0.12. See pretty good reaction from this as well in comparison to the other instruments. And probably quite a bit more accurate as well. 11.26. That's the 8846A in operation there on the decade box. It will measure. I'll just pop it into the 300 microfarads so you'll see how close that is. You also see how fast it operates as well. We'll try the 1 millifarad. And that's got 1 millifarad as well. But seeing it on this does tend to show you how inaccurate the MTR105 was. Just flip it onto the 10 millifarad. So there you go, pretty accurate in comparison to the Keysight, to be honest. That was 10.46 when it wants to read, but obviously a much faster reading. So that brings me to the close on this video on capacitance measurements. For me, as I said at the beginning, all three instruments are really capable of my needs for this. But personally, I think the speed and the accuracy of the MetraHit coil, I'm going to give that first place and 5 points. I'm going to give second place to U1461A, primarily because of the accuracy, and the MTR105 I'm going to put in last place because it doesn't appear to be as accurate. It's fast, it's got the range, I accept that, but its accuracy is quite a bit down when compared to the other two instruments. So that's it for this video. Thanks for watching, hope you enjoyed it. I'll leave you with a table of the results I've made from the decade box, and I'll see you in the next video on the MTR105, which will be on the inductance function.